Sizing the surface area, basically it's square feet of your surface times the gallons that we calculated that we need, divided by your precipitation density in inches. The 1.6 is just a conversion factor of 12 feet per inch and 7.5 gallons per cubic foot. So that's just a math issue there. What we don't show in this thing is the time element, whether that's per week, per month, or per year. And that basically is the engineering judgment that you'll need to find out. Again, keeping in mind, as we said, the rainy season may not be tourist season. As far as the roof itself, that is the horizontal projection of the roof. If you have a pitched roof, it's not the combined surfaces. The thought being that rain kind of falls straight down. Materials to be used. A lot of the rubber roofing things tend to be NSF approved, and that you can basically take the water off without a whole lot of problems, providing that you keep your surfaces clean. If you're talking shingled roofs, asbestos shingles, they're not recommended for potable water. If you do use it for non-potable, then the issue becomes filtering out the grit and the sand. If you're talking wood shingled roofs, the danger there is that sometimes they're treated with a microbial thing to keep the mold from growing, which may not be good for your plants. So you need to pay attention to what you've got. Generally speaking, a metal roof is good, particularly if it's painted with an NSF coated paint. Cleanable, non-contaminated surface. As somebody pointed out, and I'll come back to later, is that the rainwater itself is not the problem. The problem tends to be your collection service. So it basically needs to be something that is easily cleaned and maintained. Somebody mentioned earlier that the problem with rainwater systems is much like a swimming pool, much like a well. It's on the onus of the owner to maintain it. Next variable is sizing the volume. The volume becomes basically the demand out minus available water in. And then plus the leakage factor that you have. ARCSA has a very nice methodology that you can download at no cost off their website. And what this does is it allows you to kind of do a little bit of iteration. Okay, you configure your square footage, and this represents the roof of my garage. We have estimated the internal is basically for a gardening use, so I just made a swag at what it'd take to water my tomatoes. Putting in a storage gallon, what I found out was that the cheaper 55-gallon drum doesn't work, so we put in a 90-gallon, and then sure enough, it basically runs out right about where it predicts here. Now, you see I've got two columns. One is the average rain density, and the other is the mean rain density. So a program like this allows you to do some sensitivity analysis. Maybe you want to put in the driest month just to find out what sort of, how the impact of your collection area and your storage, just what sort of interaction that'll play as far as your situation goes. System design techniques. Again, once we get our system over here, again, we kind of qualify the fact what part of the design wants to be potable versus non-potable. This is a typical design, and this is something we picked up from the Germans. It has a couple of interesting things about it. We have, first of all, our first concern would be to take the leaves and the debris off the roof. They have a filter, and there's a variation of this. This is basically what we would call a medium capacity filter. It's manufactured by a company called WISI, and is now being represented by J.R. Smith here in the United States. Basically what that does is it acts as a pre-filter. It allows all the debris to come off the roof before the good water then goes into your tank. Now there's variations of this, and a lot of them are kind of site-specific as to what you actually need. It may well be that in parts in Indiana, all you need is basically a leaf separator. If you have something on the West Coast, I'm told that tree pollen, when it gets a little wet, it just makes kind of a goo and will plug things up. In that case, you may want to have a little bit longer period of time where the water is wasted. Typically, you want to waste the first 10 gallons, the first 20 minutes of rain, the larger of the two quantities. As the water comes in, it goes through this thing, and then comes out and comes down into the tank. What they recommend, and what's recommended, is what they have called quiescent flow. Rather than just kind of slosh the water in and stir up the sediment in the bottom and aerate everything, what they like to do is kind of just bring the water in as gently as they can at the bottom of the tank. And then as it fills up on the far side, it then kinds of bubble. Anything floating then is pushed over to the overflow. And the overflow / skimmer, that'll basically take care of anything that is accumulating at the top. You want to keep the top of your tank clean, because if it blocks off, then it gets sort of anaerobic in the bottom, and it starts getting, the flavor of the water starts getting impacted. You then have a check valve or some means there to keep the mosquitoes and the critters from getting into your water storage tank. The water pickup is a device that has a float on it, and what the intent there is, this is actually the water pickup point, this being the float. You'd like to basically keep it floating off the bottom but below the surface where the cleanest of the water in your tank is. You then pump it out and into your system. The pump, they have a lot of variable speed pumps that are basically controlled to maintain static pressure in your system, or you can go to a standard well type situation where you basically pressurize into a pressure tank. Goes into your system. Here basically you may have if it's available, a manual fill. People in Australia, there's a company called Davy Pump, a product called Rainbank that basically works in concert with your tank. That when the tank goes dry, it then will automatically flip over to what they call mains water over there. And then it goes to into your facility there.